Welcome to 3 Minutes With, where we meet researchers and their precision agriculture projects. Today we have Rob Bramley from CSIRO to talk to us about the Future Farm project.
Thanks, Nicole. So what I want to do today is to make some introductory comments about Future Farm as a lead into a series of videos that you'll see from different members of the Future Farm team. They'll be providing videos to spar subsequently. I guess everybody's familiar with the idea of the 4 R's, the notion of putting the right rate of the right product in the right place at the right time. But I think we sometimes should be asking ourselves whether 4 R's are enough. So for example, do we have the right equipment? Are we pursuing the right objective, whether that be in terms of yield or quality or both? And how do we know what right is? Do we have the right data? Does this data have to just come from on farm? Are we making use of it at the right scale? How do we think about growers' risk in implementing the 4 R's? And would some on-farm trials be useful to assist with getting things right? And I guess that fundamentally Future Farm is a project that seeks to tackle some or all of these questions in different combination. And in particular, the project aims to re-examine and improve the way in which soil and crop sensors and data from elsewhere are used to inform decisions about input management. And also we're particularly interested in automating the process from data acquisition through its analysis to the formulation and implementation of decision options. The initial exemplar use case is nitrogen fertilizer management in wheat, largely because nitrogen fertilizer accounts for such a significant proportion of the input costs of production. But Future Farm's not a nitrogen project per se, it's more about the use of the sensors and the automation. And contrary to popular rumour, it's not about robotics. I guess the other thing that's important to say about Future Farm is that it's a collaborative and co-funded effort involving input from CSIRO, the Universities of Sydney, Southern Queensland, Agriculture Victoria, the Queensland University of Technology and the GRDC. Now, if we think about a typical agronomic decision, such as a decision as to whether or not to apply fertiliser, we might typically use our mechanistic knowledge to identify a series of agronomic parameters, and measurements of these are coupled together in some sort of decision support system to help us arrive at our decision. But since the advent of various ag technologies and precision agriculture, we now have a range of sensors that we use to help make these measurements of agronomic parameters. And whereas some of these sensors are easy to calibrate, things like yield monitors or soil pH or moisture sensors, some of the other ones are not so easy to calibrate. And I guess a lot of effort has been put into generating calibrations of these various sensors to make measurements of these agronomic parameters. But the question arises as to whether or not that's the most sensible approach. Meanwhile, some service providers are using some of these sensors just as singular inputs to a decision and trying to generate recommendations about decisions without considering whether or not more information would be desirable. And in Future Farm, one of the underpinning ideas is that most agronomic decisions are really multivariate issues. So they need to factor in multiple inputs. So in other words, multiple soil or crop sensors. We might draw on data that's historical from on-farm or broader publicly available data, such as weather data or soil data, and indeed crop models. And a second important underpinning idea for Future Farm is that some on-farm experimentation could make a key contribution in making our decision much more site-specific, which is obviously what we want to do in a precision agriculture context. So instead of drawing on or following this kind of pathway to a digital decision, in Future Farm, what we're doing instead is saying, well, we'll use our mechanistic model to choose some appropriate sensors. And the ones that are easy to calibrate, we'll continue to put effort into calibrating. But the ones that are more difficult to calibrate, we won't worry so much about calibration, and we'll just use the data that they generate, and we'll combine all of that in some sort of data-driven model that's further informed by some on-farm experimentation and also data acquired from off-farm sources, and perhaps at a scale much broader than the whole farm, and use those various different data sources to derive a sensor-based, data-driven and targeted decision. And what you'll see in the following series of videos is various members of the Future Farm project team talking about research that they're doing that addresses particular parts of this framework in order to enable us to come to this sensor-based targeted decision. So I'll leave it at that. Hopefully you gain some value from this series of videos, and ultimately gain some value from the Future Farm project overall. So thanks very much.